This is Geometry, Section 5.6, Inequalities in one triangle. So, first thing we're starting with is the biggest side, biggest angle theorem. So this theorem says that in a triangle, the biggest angle is across from the biggest side, smallest angle is across from the smallest side, so smallest angle, smallest side, etc. So on and so forth. So the medium angle is obviously across from the medium side, and this also goes both ways, so also vice versa. Okay, so the smallest side is across from the smallest angle, biggest side is across from biggest angle, medium across from medium. So it says list all the angles of the triangles from smallest to largest. Well, if we look at the sides of this triangle, we've got 8, 9, and 12 in that order from smallest to largest. So 8 is across from angle R, so that would make angle R the smallest angle. 9 is across from angle P, so that comes next, and 12 is across from angle Q, so that's the biggest. Same thing here, 24 is the smallest number out of all of these, so angle N comes first, 31 is next, so S is next, 32 is the biggest, so W is the biggest. Here, this is a problem just like a couple sections ago that we had where we haven't really learned this yet. This deals with the three sides of a right triangle, so if we call this one A, this one B, this one C, C is always, we call C the hypotenuse, which is the side across from the right angle. So we have something called the Pythagorean theorem, which we have not learned yet this year, that says a squared this side plus b squared this side equals c squared this side. So if we set this up, a squared plus b, which is 42, squared equals c, which is 58, squared. If we solve this, don't worry too much about solving it right now. If we solve this, we get that b equals 40. So this side is 40. So we've got 40 is the smallest side, which makes angle C the smallest side. 42 is the next, which makes angle A the next. And 58 is the biggest, which makes angle B the biggest angle. Alright, going backwards now, this says list the sides of the triangle from smallest to largest. So now we're only given two angles because we know how to find the third angle given two of them. We add them up and subtract from 180. So if I do that with 80 and 35, I add that up and subtract from 180, I get 65. So 35 is the smallest number, which makes this side, DB, the smallest. Next is 65, so BA is next, and 80 is the last one, so DA is the biggest. Same thing here, add 90 and 31, subtract it from 180, you get 59. 31 is the smallest, so RU comes first. 59 is next, so RN comes next, and 90 comes last, so NU across from that comes last. This one, first we've got to figure out this angle right here in order to figure out this angle right here. So 122 is an exterior angle. If we subtract it from 180, because these two things add up to 180, we get 58 right here. And then if I add 58 and 60 and subtract that from 180, I get 62 for N. So here, 58 is the smallest number. MS is the smallest side. 60 comes next, so MH comes next. And 62 comes last, so the side across from that, SH, comes last. These ones are a little bit trickier. We've got two overlapping triangles. So since we're going smallest to biggest, so these letters now represent the names of the sides instead of using two letters. We're just going to use one letter, like all of these, to represent the sides. So since we're going smallest to largest, we're going to start with the smaller triangle when we're determining this. So first, let's figure out all of the angles. So if I add up 145 and subtract from 180, I get 35. If I add up 95 and 30 and subtract from 180, I get 55. We'll do the same thing over here before we start. 40 plus 80 gives me 120. Subtract that from, 40 plus 80, 120. Subtract that from 180, you get 60. 75 and 70 added together. Subtracted from 180 gives me 35. So now we filled in all the angles. Now we start with which side is the smallest. So again, this triangle over here is smaller than this triangle, so we'll start with this one. smallest angle here is 35, so the smallest side has to be E. The next one is 45, so the next one would be H, and the biggest one is 100. So the biggest side in the small triangle is W. So now if we look at the big triangle, the smallest angle is 30, which is across from W. So we're still in the right order. W would come next. 55 is the next one. That's across from K. So K would come next, and 95 is the biggest, so G would be the biggest side. Same thing over here, start with the smaller triangle. So 40 is the smallest angle, which makes D the smallest side. 60 comes next, so M, and then 80 means V comes next. V is also across from 35, which is the smallest angle in the bigger triangle, so we're still in the right order. And then we've got 70 comes next, that's smaller than 75, so A is smaller than C. Alright, list the sides of the triangle from smallest to largest. First we need to figure out what all of these angles are, because we don't have numbers, we have expressions. So we know that all three angles of a triangle add up to 180. So if I add all of this stuff together, 3x minus 5 plus x plus 25 plus 2x plus 10, all of that should equal 180. 3x plus x is 4x plus another 2x is 6x. Negative 5 plus 25 is 20 plus another 10 is 30 equals 180. Now I have to subtract 30 from both sides. 150 equals 6x. When I divide by 6, I get that x is 25. So if x is 25 and I plug that in here, plug it into this one, 2 times 25 is 50, plus 10 is 60. So this is 60. 25 plus 25 is 50. 3 times 25 is 75, minus 5 is 70 right here. So 50 is the smallest. It says go from smallest to largest, and it says list the sides, not the angles. So 50 is across from this side, which is RU. So RU is the smallest. 60 is across from RN. And the last side across from 70, UN. Alright, solve the following inequalities. So this is review from Algebra 1. So we solve an inequality just like we solve an equation. Here I've got x plus 3 is less than 14. So to solve for x, I just subtract 3 from both sides. X is less than 11. Here, I would have to subtract 5. So 11 minus 5 is 6. Negative x is greater than 6. When I divide this by negative 1, I have to flip the inequality sign when I divide by a negative. So this would become x is less than negative 6. Same thing here. So when I subtract 15, 1 minus 15 is negative 14. But then I've got negative 2x here. So when I divide by that negative 2, that turns into x is greater than positive 7. Alright, we're going to skip over this briefly, talk about this, and then we'll come back to those lines up there. So the triangle inequality theorem says if you've got a triangle, side lengths A, B, and C. So A, B, and C are the lengths of a triangle. Then, any two sides must add up to more than the third side. So what this means, so if I take any two of these sides, so if I take A and B and add them together, that has to be greater than C. If I take A and C and add them together, that has to be greater than B. And if I take B and C and add those together, that number has to be greater than A. So, going back up here, it says determine which of the following pairs of segments along with PQ could form a triangle. So PQ is 24 units long. So we have to determine is 8 plus 12 greater than 24. 8 plus 12 is 20, which is not greater than 24, so this would not work. Same thing, 4 and 16. If we add 4 and 16 together, that also only equals 20, which is not greater than 24, so this would also not work. 16 plus 16 is 32, which is greater than 24, so this would work. We also have to check to make sure 16 plus 24 is greater than, so these two sides is greater than this third side, which obviously it is, because if I add something to 16, it's going to be bigger than 16. So this one would work. This one, same thing. 12 plus 20 is again 32, which is greater than 24. So that would work. If I check 24 plus 12, that's also greater than 20, and 20 plus 24 is greater than 12. So all three combinations work. So this is yes. Here, if I add 8 and 36, that is going to be bigger than 24, since 36 is already bigger than 24. But if I add 8 plus 24, that only equals 32, which is not greater than 36. So since these two sides added together would not be more than this side, this would not make a triangle. So, which of the following could form a triangle? Explain your answers. So we just have to check to see if all of the combinations work. Is 2 plus 5 greater than 8? Well, 2 plus 5 is 7, which is not greater than 8, so automatically this one doesn't work. If we check here, 9 plus 4 is greater than 6. 4 plus 6 is 10, that is greater than 9, and 9 plus 6 is greater than 4. So yes, that works. Here, 7 plus 8 is greater than 3, that works. 8 plus 3 greater than 7, that works, and 7 plus 3 is greater than 8. So these all work. Here, 2 plus 5 is greater than 3. 2 plus 3, however, is not greater than 5. It's equal to 5, but this has to be strictly greater than 5, because if I tried to take a segment 5 units long and put a segment 2 units long and 3 units long on top of it to make a triangle, these two segments would have to lay flat on this segment down here in order to stretch all the way across, and that wouldn't make a triangle, it would just make a line segment. So this does not work. Alright, if a triangle has two given sides, find all possible lengths for the third side. So here, all we're going to do is just figure out the difference of these sides and the sum of these sides, because the difference would be the smallest number that could be the third number of the triangle, and the sum would be the biggest number that could make the third side of the triangle. So if I subtract 14 and 10, I get 4, and if I add them, I get 24. So x has to be in between 4 and 24 in order for these three numbers to make a triangle. Same thing, 3 plus 12 gives me 15. 12 minus 3, we always want to make sure we're subtracting the smaller one from the bigger one. So 12 minus 3 gives me 9. So x has to be in between 9 and 15 in order for x, 3, and 12 to make three numbers that can form a triangle. 40 plus 49 gives me 89 for the biggest one, and 49 minus 40 gives me 9 for the smallest possible side. Last problem, a student has an 11-inch piece of wire that she wants to bend into an isosceles triangle. Isosceles again means that two of the sides are the same. And the length of each side must also be a whole number. Lists all the possibilities. So we've got 11 inches to work with. If we go 1 and 1, so let's say the two congruent sides are 1, we have 9 pieces of wire left over. But pieces of 9 inches of wire, excuse me. But 1 plus 1 is not greater than 9. So this would not work. That wouldn't make a triangle. Let's check the next possibility. So if we have the two congruent sides being 2, then we have 2 and 2, which would add up to 4, so the leftover piece would be 7. But again, 2 plus 2 is not greater than 7, so this also would not work. Let's try 3 and 3. So if we have 3 and 3 inches, then that adds up to 6, so there's 5 left over. 3 plus 3 is greater than 5, and 5 plus 3 is greater than 3, so this would work. So this is one possibility for a triangle. If we check the next one, 4 and 4. 4 and 4 adds up to 8, so the leftover piece would be 3 units long. So we've got 4 and 4 adds up to more than 3. 3 and 4 adds up to more than 4, so this would work. Next possibility, 5 and 5, so that adds up to 10, so there would be a piece 1 unit long left over. 5 plus 5 is greater than 1, and 1 plus 5 is greater than 5, so this works. If we check the next one, 6 and 6, that puts us over 11 inches. And we've only got 11 inches to work with, so these are the only possibilities.